Now let's see something called as demand paging. See, coming to page replacement algorithms, we have not seen any algorithm so far, right? Now what we are doing is we are actually discussing small concepts so that it will be very helpful while discussing page replacement algorithms, right? That's the reason I'm discussing these small concepts. Okay, you might not be able to understand it exactly right now, but after some time, once we see page replacement algorithms one by one, you'll be able to understand everything very clearly. Okay, we are going to take a lot of examples. Fine. Now what is meant by demand paging is we will not load any page of a process until CPU requests for a byte in that page. Right? See this. Let us assume we have a process P1 which has 4 pages named page 0, page 1, page 2 and page 3, and it has been told that P1 process P1 has been allocated 2 frames. Right? Let us assume these 2 are the frames which are allocated to process P1. Okay, these 2 are the frames which are allocated to process P1. Now initially no page will be loaded inside the RAM until CPU requests for a byte in that page. What do I mean by this is, see, as of now the RAM is empty, right? As of now the RAM is empty, no page has been loaded. Let us assume CPU requests for a byte in page number 2, right? Page number 2 has lot of bytes, right? Page number 2 has lot of bytes. Now let us assume CPU requests for a byte in page number 2. Now in this case, I will load page number 2 inside the RAM. Right? I will load page number 2 inside the RAM. Now as long as a byte has been requested in page number 0 or 1 or 2 or 3, we will not load that page inside the RAM. That is what we mean by demand paging. Demand paging means a page will be loaded into the RAM only on demand. We will not load it before, right? Initially we see these 2 frames are allocated to process P1. Now I could have easily maintained 2 pages inside the RAM either way, right? Rather than keeping this frame as it is, which means rather than wasting this frame or keeping this frame empty, I can maintain 1 page so that whenever CPU asks for a byte, it can fetch it and execute it without page faults, right? Now in case if I'm keeping this page as empty, now in case if CPU requests page number 1, byte in page number 1, I might have to load page number 1 inside the RAM, which is actually causing 1 page fault, right? So this is the problem with demand paging, but demand paging is used these days. Demand paging is very popular these days, okay? See, one important point you need to notice here is, in case if I am using demand paging, every page will at least lead to 1 page fault, right? Why? Because we are not going to load any page before a byte has been requested by CPU in that page. Now whenever CPU requests for a page for the first time, definitely it will lead to page fault. Why? Because that page we should not have loaded inside the RAM. Why? Because this is the first time CPU is requesting for a byte in that page. So I would not have loaded that page before itself inside the RAM, right? So every page will lead to at least 1 page fault. We know what is meant by page fault, right? Whenever CPU requests for a byte in the page, in case if the page is not present in the RAM, that page has to be loaded from hard disk into the RAM. That is what we mean by page fault. Now in case if CPU asks for page number 1, CPU will always ask for a byte or word, right? It will not request a page. So in case if CPU requests for a byte in page number 1, since page number 1 is not present, we might have to take page number 1 and place it here, right? This is leading to 1 page fault, right? Now in case if CPU requests for page number 3, what will happen? Since these 2 are the frames which are allocated to P1, since I am assuming that we are using local page replacement algorithm, so page number 3 has to be placed in either of the 2 frames, right? With this frame or this frame. Now which frame should I replace? That depends on page replacement algorithm, right? Which algorithm we are using, whether we are using least recently used or first in first out or whatever it is. We will see that later, okay? So what I want you to understand here is, demand paging means we will not load any page until CPU requests for a byte in that page. We have loaded page number 1 and page number 2 over here in the RAM because CPU has requested once. CPU has requested a byte in this pages, right? I have not loaded page number 3 over here because CPU has not requested any byte so far, right? So that's what we mean by demand paging. In case if you are not able to understand demand paging very well, it is perfectly fine because we are going to see a lot of examples. Once we see page replacement algorithm, it will be very easy. Okay, it is a simple concept. Fine.